This is the Shell and Tube Heat Exchanger project,
I'm Dan Seiderman.
and I'm Ryan Clark. The problem statement at hand is the MSU High Performance Computer Center needs us to design an alternative cooling system because the cost of the standard refrigeration unit is high.
Some of the design parameters that we're working with is that we want to be able to take 1 megawatt of thermal energy out of the system using 10 to the 6 gallons per day of water from a reservoir. The system that we'll be using is a tube and shell heat exchanger, as can be seen in the image. We want the heat exchanger to be easy to clean, have a minimum pressure drop, and be compact.
The approach that we'll use for this project is with Aspen Exchanger Design and Rating version 8.8. The configuration of heat exchanger we chose to use is with the front head type A and a rear head type L. These both have removable covers which will allow for easy cleaning. We also chose to use a shell type E, which is a one-pass shell, so the water does not get too hot.
Some of the constraints that we're working with is that we have a 14-inch inner diameter pipe leading into the system. We want the heat exchanger to be no more than 20 feet in length. We want no more than a 3 degree Fahrenheit temperature increase in the water, and we want the hot stream liquid to be between 90 degrees and 100 degrees Fahrenheit.
There were two fluids used within this experiment. The cool fluid being water. This water is extracted from the MSU reservoir and it is used to cool the high performance computer center. The hot fluid is called propylene glycol. We chose this fluid because it is non-hazardous and it also has a thermal conduction property of 0.8 BTUs per pound degree Fahrenheit.
In the image on the right is the data from the Aspen software. There is only a 3 degree Fahrenheit increase in the water temperature. The pressure drop is within standards. The propylene glycol is within its expected temperature ranges. And there is 1,052,461 BTUs per hour energy exchanged.
The results gathered from the Aspen program let us know that it is not possible to replace the refrigeration unit with a single heat exchanger and our current constraints. We are only able to provide about 1/3 of the energy required. It may still be cost effective to purchase the heat exchanger and be able to use 1/3 less energy from the refrigeration unit though.
Some potential suppliers are Sheco, Southern Heat Exchanger, who provides customizable heat exchangers, and the total cost would be around $80,000.
The codes and standards are below. We both read through these and we found out that the maximum allowable working pressures are within the code and that the strength of materials are within the code for the carbon steel. Any questions?